Afternoon, everyone. So here with me we are doing the introduction to calculus. So the first introduction to calculus deals with differentiation. So differentiation can be used to find what we call the gradient function. When we say the gradient function, it is a function that can be used to find the gradient at any point on the curve. So now, the first thing that we will look at is how we are going to differentiate. So we are asked to say differentiate the following. So the first one is differentiate 2x squared plus 4x plus 6. So the first rule that we are going to be looking at is the power rule, differentiation by the power rule. So for this one, the solution will be, in order for us to differentiate, we are going to say we have 2x squared plus 4x plus 6. So now, these terms, all of them have got x, including this 6. Now, to maintain the meaning, we can just say this is the same as x raised to the power 0. We remember to say any number or any letter raised to the power 0 is equal to 1. This does not change the meaning. So, upon looking at that, we are going now to differentiate by the power. So, this is how it works. So, we have this power, it should be able to multiply this coefficient. So, we have 2 by this power has dropped. So 2 by 2x squared. Now I have said to say power rule. So just remember to say differentiate, or remember the word difference, meaning to say we are subtracting. So we subtract 1 from the power. So we have that, then plus this 4x is the same as 4x raised to the power 1. We are going to multiply 1 times 4 our x raised to the power 1 and then subtract 1 from the power. Then we have plus. Now, if we have an equation like this, this is this. When this power goes that side, we have 0 times whatever we will have. Still, the answer will be 0 because any number multiplying by 0 is what? 0. So our answer will be dy over dx, which is the differentiation part. So we have 2 times that, we have 4x plus. Here we multiply 1 by this, we have 4, then 1 minus 1 is 0. So we have 4x raised to the power 0. So we have 4x, any number raised to the power 0 is equal to 1. So plus, we have 4 as our answer. So any equation that is differentiated should be expressed as dy over dx, which is differentiating y with respect to x. So all the terms that have got x, we are differentiating them or giving them respect in other terms. So looking at B, maybe we might have y should be equal to 3x raised to the power 3 minus 4x squared plus 5. So we are going to do the same. So we are going to say dy over dx should be equal to, we have the power, it should drop. So we have 3 by 3x raised to the power 3. Then subtract by the new power, which is minus 1. Then minus, we have these 2. 2, when it drops there, we have negative 2 times 4x squared, we subtract by 1. Then plus, we have here the derivative of the constant number is equal to 0. Any number that does not have x is always equal to 0. So we are going to say dy over dx should be equal to our 3 times 3 gives us 9, x 3 minus 1 gives us 9x squared, then we have minus 8, 2 minus 1 gives us x. So our answer is 9x squared minus 8x. Our last example for the differentiation part is, let's say we have y should be equal to 1 over 3x cubed, then minus 1 over 2x squared. So let's say we have that problem. So how do we differentiate it? So when we are told to differentiate, it is the same principle. So how are we going to do it? We are going to say why we are going to differentiate, which is dy with respect to x. So we are going to do that. Then here we have the power. So we are going to drop the power and say 3 times 1 over 3 x is raised to the power 3. Then subtract by 1. We have minus 1 minus, we have 2, it will be dropped there. We have minus 2 times 1 over 2 x raised to the power 2 minus 1. So we are going to cancel this and this. So we are remaining with x squared minus, we have this 2 and that. So we are going to cancel. We have minus x. Now 2 minus 1 is 1. So our answer for dy over dx is equal to x squared minus x. That's how we introduce the thing about differentiation under calculus. Thank you very much.